Today, we'll cover one of the most critical settings in TIG welding that directly affects weld quality when welding aluminum: the balance setting in alternating current. Balance determines how long the alternating current stays in the electrode negative and electrode positive phases. To put it simply, electrode negative provides penetration and electrode positive cleans oxides. The percentage value you see on the machine usually represents the electrode negative ratio. When the electrode negative ratio is high, the majority of the current operates in the electrode negative phase. This means that most of the heat goes into the workpiece. Deeper and more controlled penetration is achieved. The arc becomes narrower and more stable, and faster travel speeds are possible. However, the oxide cleaning effect is reduced. It is preferred for clean and thick aluminum parts. When the electrode negative ratio is low, the duration of the electrode positive phase increases. In this case, the oxide cleaning effect increases. The surface appears brighter. However, the tungsten service life is shortened and penetration is reduced. It is useful on dirty or oxidized aluminum surfaces, but it is not suitable for continuous use. The most ideal balance setting for aluminum welding should be 70 to 75% electrode negative. In this range, you get sufficient oxide cleaning, solid penetration, a stable arc, and a long tungsten life. So, what happens if the balance settings are adjusted incorrectly? The oxide layer won't be broken down sufficiently. The weld bead will look dull and dirty. Penetration weakens, tungsten life is shortened, and the risk of porosity and defective welds increases. In summary, balance is one of the fundamental settings of aluminum TIG welding. A high electrode negative ratio provides deep penetration and a narrow arc. A low electrode negative ratio, on the other hand, creates a strong oxide cleaning effect. That concludes our guide explaining how the AC balance setting affects the oxide cleaning action, penetration, and arc stability. If you found this video helpful, be sure to like it, and don't forget to subscribe to the channel for more TIG welding training. We'll see you in our next video.